Before we move into the part of this unit that applies algebra into the real world, let's practice some of those important introductory skills. When we started in this unit, we talked about some really important vocabulary. As we continue working through this unit, we want to make sure we have these 4 major vocabulary words memorized. Okay. We have terms, which refer to the parts of an expression or equation. We have variables, so we need to know that variables are the letters or the symbols, and we need to know that we use them because they are representing an unknown value. Connected to variables, we have a coefficient. That is the number that is attached to it, and we'll see in this that a coefficient will multiply the value of the variable. Really important to understand that a number that is right next to a letter is multiplying it. Finally, we have constants, and those refer to our numbers that don't have a variable. Okay, in our equations and expressions, if we see a constant, they don't change. So we're not doing anything to affect the change in a constant. So we need to know that vocab, and let's apply it to identifying the parts of this equation. The first thing I'll identify are the total number of terms. So I'm just going to count how many terms there are. Okay, the terms refer to any of the parts, so 7y is one term. Each term is separated by an operator, meaning a plus sign, a minus sign, and so on. So we have 7y and minus 8. Those are 2 separate terms. And on the other side we have 2b and 9. So if we're counting the total, there are 4 pieces to this equation. If I'm listing out the variables, I just want to know the letters, so I don't want to include any of the numbers. In this we have a y and we have a b. Connected to our variables are the coefficients. So what number comes with the variable? With y, it's connected to a 7, so that would be 7 times y. And with b, we have a 2, so that's 2 times b. Finally, I'm looking at my constants. Okay, and the constant is a number that we see that doesn't have a variable. When you identify a constant, pay attention to the sign in front to determine if it's a positive or negative. So the first number I see that doesn't have a letter with it is the 8, and that has a subtraction sign in front, so we would call that a minus 8. Okay, the 7 is connected to a y, so that's not a constant. Likewise, the 2 is connected to the b, that's not a constant. However, the 9 is all by itself with no letter. That is a constant, and because we're adding it, we'll call it a positive 9. When we continue in this unit, we start evaluating expressions using substitution. Substitution means I know the value of the variable, and I want to find the value of the whole term or expression. When we substitute, it's really important to remember that a number next to the letter will multiply it. Okay, this does not become 819 because u is 19. To help you remember that, I often will put that substituted value into parentheses. To remind myself, again, this is not 819, it's 8 times 19. I'm going to go ahead and multiply to figure out this value. When we substitute, we should be able to find one whole number response here. When we add terms to the expression, so we have 2 terms in this expression, it can be a little bit more difficult to evaluate. Okay, remember, just like we did in the last problem, when I'm replacing w If there's a number in front, that will multiply. So let me rewrite this to show that. That's 3 times w minus 14. When I go to replace my w, I am not changing anything else about the problem. So underneath the original problem, where I see a w, I'll put that 18. And I'm going to keep everything else about this the same. So 14, the constant, can't change even though w is now given to us. And 3, the coefficient, is still 3. Next, I will multiply those two values, the coefficient 3 times 18. I would suggest doing this out to the side as to not confuse yourself. Okay, and again, the minus 14 is staying the same. As I'm working my way down, I'm simplifying the expression one step at a time until I can arrive at a final answer. So I can do 54 minus 14 will give me an answer of 40. Finally, we've talked about how we solve an equation. Okay, so let's notice the difference. If it's an expression like these previous ones, we can evaluate it and find a number. But when we see the equal sign, what we're going to be doing is solving. Solving for s means let's find the value that will make this a true statement. Instead of guessing and checking like we did to start, we're going to start using the inverse operation to find the value for the variable. Inverse means opposite. So when I go to solve this equation, I'm going to rewrite this as 9 times s, because 9 is a coefficient. I want to identify what is being done to the variable. So in this problem, s is being multiplied by 9. And I want to figure out, again, s equals what number? So my goal is to get s all by itself, which means I need to get rid of times 9. When you're solving an equation, you're going to do the opposite operation. So if you see the variable being multiplied, you're going to divide. Okay. Division and multiplication are opposite of each other, which means they'll cancel each other out. So this times 9 and divide by 9 cancel out, leaving the variable s all by itself. However, an equation needs to stay balanced, so I'm going to divide on both sides of the equation. So, last step, again, I'm going to do my work out to the side. 9 goes into 20 2 times. 9 times 2 is 18. Bring down the 7. 9 can go into 27 3 times. And these problems should not have a remainder for you guys to start. So I've solved this equation for s equals 23. If you want to double check your answer and make sure it's right, all you need to do is replace the s in the original problem with that value you got. So if I replace s with 23, I have 9 times the 23 equal to 207. And when I do this, 9 times 23 does give me 207. So I know I have the right value. If you had gotten anything other than 23, this would not come out to be true. All right, my last one. Okay, I'm solving another equation here. So what I'm going to do is I'm immediately looking for the variable j, and I want to know what is happening to it. In this problem, j is getting subtracted. So to eliminate subtraction, I'm going to do the opposite And the opposite of subtracting is to add. Again, if I use the opposite operation, then these two pieces cancel each other out, leaving j by itself. And just keeping it balanced, because I added 46 on the left side, I'm going to make sure I add 46 on this side, which tells me j equals 327. Again, if I want to check this answer, if I replace the j in the original problem with this new value, let's make sure it's a true statement. So if I subtract 327 minus 46, it does indeed give me 281. So I can prove my answer is correct by double checking. As we continue to practice these basic skills necessary, keep in mind the small details, take your time, and practice makes perfect.